In 1921, Albert Einstein received the Nobel Prize in Physics. Because the special theory of relativity was still a controversial topic, the Nobel Committee awarded him the prize for his explanations of the photoelectric effect and his contributions to physics. It wasn't until later that the enormous impact of his theory of relativity was realized. Thanks to Einstein, our perception of the universe was completely changed, and it even helped shape the world we live in today. The space-time relationship. One of Einstein's earliest achievements at the age of 26 was the special theory of relativity. It is called special because it deals with relative motion in the particular case where gravity is ignored. This may sound innocuous, but it was actually one of the greatest scientific revolutions in history, completely changing how physicists think about space and time. Previously, we thought of space and time as entirely separate because they were measured with different units, such as kilometers or seconds. But Einstein showed how they could actually be interchangeable, linked together by the speed of light at approximately 300,000 kilometers per second. The most famous consequence of special relativity is that nothing can travel faster than light, but it also means that things start acting very strangely as the speed of light is approached. Typically, if you could see a spacecraft moving at 80% of the speed of light, it would appear about 40% shorter than when it is at rest. If you could see inside this ship, everything would appear to move slowly, with 100 seconds corresponding to the marking of 1 minute, according to measurements by hyperphysics at Georgia State University, USA. This means that the spacecraft's crew would actually age more slowly as they travel faster. An unexpected offshoot of special relativity is Einstein's famous equation E=mc². This may be the only mathematical formula to achieve cultural icon status. It is famous because the equation expresses the equivalence of mass, dI, amperes, and energy, E$, two physical parameters previously thought to be completely separate. In traditional physics, mass measures the amount of matter contained in an object, while energy is a property an object acquires through its motion and the forces acting upon it. However, Einstein's equation says that mass and energy are fundamentally the same, provided you multiply the mass by c², or the square of the speed of light, a very large number, to ensure that it ends up in a unit of energy: lasers. Lasers are an essential component of modern technology. They have many applications, from barcode readers and laser mice to holography and fiber optics. Although lasers are not often associated with Einstein, some of his work made them possible. In 1959, the concept of the laser was born, which stands for light amplification by stimulated emission of radiation. Meanwhile, stimulated emission is a concept that Einstein developed more than 40 years earlier, according to the American Physical Society. Einstein realized that the new photons travel in the same direction, with the same frequency, and in phase with the original photon. This leads to a cascade effect, where more and more nearly identical photons are created. Black holes, wormholes. Einstein's special theory of relativity showed that space-time can cause some strange things to happen, even without a gravitational field. He discovered that massive objects like planets and stars actually distort the structure of space-time. It is this distortion that creates the effects we perceive as gravity. Einstein explained the general theory of relativity through a complex set of equations, which have many applications. Perhaps the most famous solution based on Einstein's equations comes from Carl Schwarzschild's solution in 1916, when he alluded to a black hole in the universe. Besides that, a solution that Einstein himself developed in 1935 describes the possibility of shortcuts from one point in space-time to another. Initially, this concept was named the Einstein-Rosen bridge, with Rosen being the name of Einstein's collaborator, Nathan Rosen. Now, they are known by the more familiar name of wormholes. The expansion of the universe. One of the first things Einstein did with the equations of his own general theory of relativity in 1915 was to apply them to the universe. However, there was one problem he could not account for. The structure of space always seemed to be in a state of continuous expansion. The consequence is that it affects galaxies, causing the distance between them to increase constantly. Noticing something was wrong here, Einstein added a concept called the cosmological constant to his equations to create a stable, static universe.